This video is to help you understand how to find the electron configuration using the periodic table. So on the periodic table, we have different blocks. We have what's called the S block, we have the D block, we have the P block, and we have the F block. I hope that you guys remember that the S orbital only has one line, and so that one line can hold 2 electrons. The number of electrons that fit inside of each orbital is going to be the same number of groups that you have inside of that block. So for the S block, we have 2 groups. If you remember, in the P orbital, you can fit 6 electrons because there are 3 lines. I hope you guys remember this. We talked about it in class. So here's an example. The P orbital always has 3 lines, always, and it can fit 6 electrons. Therefore, the P block has 6 groups. So 1, 2, 3, 4, 5, 6. Technically, helium is actually a part of the S block. That's why it says here 1s2. So helium actually belongs over here. The d orbital had 5 lines and therefore can fit 10 electrons. And notice here that the d orbital has 10 groups inside of it. Lastly, the f orbital has 7 lines. This is annoying. I don't know how to get rid of this. The f orbital has 7 lines and therefore can hold 14 electrons. And you can see here that there are 14 groups inside of the f orbital. So the way that you read this, let's say we were trying to find the electron configuration for, I don't know, let's say carbon, right? So what we've done in the past is if we've made orbital diagrams, so I can show you the long way and then I'm going to show you the short way. So let me open up Paint, brand new. So in the past, what we've done is made orbital diagrams, and we've said, okay, the first orbital I know is going to be 1s. The reason I know it's 1s is because if you come to your notes, in the notes that I gave you all, there was a slide that looked like this, and I said in the first shell, there's only one orbital, the s orbital. We already know that the s orbital can only hold 2 electrons. Therefore, the first orbital that we always start off with is 1s. The next orbital would then go into the second shell, so 2s, and then 2p. And then from the 2p, we move on to the third shell, so 3s, 3p. I told you guys in the third and fourth shell, things get weird. I said that the d orbital is actually kind of higher in energy than the 4s orbital in some cases. So you're going to see that these 2 orbitals tend to switch places. I gave you guys some information in your notes. So if you go into the class notes section, sorry, my computer's a little slow. If you go into the class notes section, I put a picture into the class notes. It's very slow. Oh, no wonder, I'm in the wrong team. There we go. So here's class notes. So there is this picture right here from 11. No. I gotta give that to first period. Alright. Here it is. So I told you guys to follow this order. So again, it goes 1s, 2s, and again, the reason that it starts lowest energy 1s, then move on to 2s, then 2p, then 3s, then 3p. So you can see it. 1s, 2s, 2p, 3s, 3p. Then instead of going directly to 3d, they actually switch. So 4s is going to come first. So I told you guys to follow this order. So if we were to have done the electron configuration for carbon in the past, we would have just started with 1s. So every time I draw an s orbital, it gets 1 line, and you draw 2 electrons. By the way, this was for carbon. So carbon has the symbol C. All right. And then on the periodic table, carbon has atomic number 6. Therefore, carbon is going to have 6 electrons if it's neutral. So 6 electrons. Technically, the atomic number tells us the number of protons, but again, if it's neutral, it's going to have the same number of electrons. All right, so I'm gonna keep adding arrows until I get to 6. So here's 1s, 2s, 2. So that's 4. So then the next one would have been 2p. The p orbital always gets 3 lines, 1, 2, 3. And then I'm going to add until I get to 6. But I'm not going to do this. Do not go, okay, cool, I got 6 electrons. You never pair electrons until each line gets 1. So instead of adding that there, I would have actually put it going here. So the rule is you always go up, 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 and only after you've gone up do you pair down. But I already have 6 electrons. See, 1, 2, 3, 4, 5, 6. So I don't have any more electrons to add, therefore I'm not going to pair. I just stop. So this would be the orbital diagram for carbon. After the orbital diagram, we then came up with the electron configuration. I said that you would write the orbital, in our case 1s, and then you just say how many electrons are inside of this orbital. So there are 2 arrows, therefore there are 2 electrons. So 1s, 2. The next orbital is 2s again, and again 2 arrows, so 2 electrons, 2. Lastly, we have 2p, so there's 2p. And then here you can see 2 arrows referencing 2 electrons again. So this would be the electron configuration for carbon. Okay, so electron configuration. I like to call it electron config because I just get lazy, but electron configuration. This over here is the orbital diagram. So 2 different things, both representing the electrons inside of carbon. So this was the orbital diagram. Okay. So that was the long way. I want to show you guys a shortcut using the periodic table. Orbital diagram. All right. So on the periodic table, if I wanted to find carbon, let me use paint and write on this. So I would circle the element that I'm looking for. You can do it in your head, but because I'm trying to show you guys, I'm physically going to circle it. So I'm looking for carbon. All right. So what you do is you start off with the first element, in our case, hydrogen. So hydrogen is inside of the S block. I already told you guys that the first 2 groups are the S block. Everything here is the D block. This is all the P block. And this down here is the F block. So this is technically 1. We're in the first row. Remember that the row is what tells us that first number in the front. So 1. Again, we're in the S block. And then I have to pass both elements. Therefore, it's 1s2. Right? From there, you move on to 2s. So again, we're in the second row now in the S block. So 2s. And again, I have to pass both of these elements in order to get to carbon. So 2s2. Right? From the 2s, you keep going across, across, across. There's nothing there. But once you get here, now I have 2p. So this is, again, the second row. But now I'm in the P block. So I write 2p. And so whatever number you stop on, that's what you write as your exponent. So I had to pass boron, that's 1. And then carbon would be 2. So 2p2. Notice you get the same exact electron configuration for carbon as you did when you did the long way. All right, let's do another example. So let's undo all of this. Get rid of all the writing. All right, the next example that I'm going to do is going to be, let's do a harder one. Let's do cobalt. All right, so again, you start off here at hydrogen. So this is the first row, so that's 1. We're in the S block, so 1s. And in order to get to carbon, I have to pass both hydrogen and helium. So that's 2, so 1s2. Right? I keep looking, there's nothing left, so I move on to the second row. All right, so now I'm in row 2, so I write 2. I'm in the S block, so I write 2s. And again, I have to pass lithium and beryllium, so 2s2, because I passed 2 elements. All right, then you keep going. Now I'm in the P block. Again, I'm still in row 2, still row 2. So 2, because I'm in the P block, I write 2p. And I have to pass all 6 of these. I have to pass boron, carbon, nitrogen, oxygen, fluorine, and neon. So I'm going to write 2p6 because I have to pass all of those elements. All right, now I'm in the third block, the third row. So you write 3. I'm in the S block again, so I write 3s. I have to pass sodium and magnesium, so I write 3s2. Right? So I keep going, there's nothing. Okay, now I'm in the P block again, but now I'm in the third row. So this is 3p, So I write 3p. Right? And I have to pass aluminum, silicon, phosphorus, sulfur, chlorine, and argon. I have to pass all 6 of them. So 3p6. Right? All right, now I'm in the 4th row. So 4. I'm in the S block again, so 4s. And I have to pass potassium and calcium. So 2 elements, so 4s2. Right? At this point, I'm in a new block. I'm in the D block. Now this is where things get weird. Like if we follow the pattern we've been doing, you would say 4D. But for the D block, I want everybody to make a note that it's always going to be n minus 1. Okay? So if you remember, n refers to the row. So this is n equals 1, this is n equals 2, n equals 3, so on and so forth. What that means is that this is the first shell. In the second row, we have 2 shells of the atom. The third row, there are 2 electron shells. The fourth row, 4 shells, so on and so forth. So even though we're in the 4th row, technically this is not 4D. It's always going to be 1 less than the row we're in. So instead of saying 4D, I'm going to say 3D. Okay, so that's the only confusing part. The reason for that is because the 4s orbital and the 3d orbital, they're very close in energy, and depending on the element that we're looking at, the 4s orbital can actually be lower in energy than the 3d. That's very confusing. For the purposes of high school chemistry, I just want you guys to trust me and say that the D block is always going to be n minus 1, and so instead of 4d, 3d. All right, now cobalt is right here, so let's see how many elements do we have to pass. We have to pass scandium, titanium, vanadium, chromium, manganese, iron, and finally cobalt. So that was 1, 2, 3, 4, 5, 6, 7. So because I stopped at 7, I write 3d7. And this would be the electron configuration for cobalt. So hopefully you see how to do the electron configuration using the